look into some important equations that we can use while doing belt drive problems. First one is velocity ratio. And suppose it is the driving pulley and it is the driven pulley, and let the diameter of this one be d1 and the diameter of driven pulley be d2, and let the rpm of drive pulley be n1 and rpm of the other be n2. Then n2 by n1 is equal to d1 plus t by d2 plus t into 100 minus s by 100, where s is the slip. If there is no slip, then take s is equal to 0, so that this time will become 1. Now, length of belt. Length of belt. We know there are two type of belt drive. One is open one. Open one is the belt will be like this, and the other one is crossed one. That means the belt will be passing somewhat like this. So, in the case of open belt, if r is the radius of the larger pulley and small r is the radius of smaller pulley, and if c is the center to center distance between the pulleys, and beta means the angle between this belt and center line, and that beta can be founded by beta equal to sine inverse r minus r by c. So if these are the given parameters, then open belt is equal to pi into r plus r minus r the whole square by c plus 2c. Here we are already said c is the center to center distance. And now, in case of closed belt, there is a single difference. This r minus r will become r plus r. So here it is like closed belt pi into r plus r the whole square minus c plus 2c. So this is the difference. So these are the length of belt, total length of the belt. Now, power transmitted by this pulley. So if T1 is the tension in the tight side, that means T1 will be the maximum tension. T2 is the tension in the slack side. Then if V is the velocity of this belt, then power is equal to T1 minus T2 into V. So T1 minus T2 means the net force acting into velocity. So force into velocity is power. So that is the power transmitted. And also T1 by T2 equal to e raised to mu theta, where mu is the coefficient of friction between belt and the pulley, and theta is the angle of contact in radians. And this angle of contact in closed belt, it is pi plus 2 beta. Beta we have already seen, it is sine inverse r minus r by c. So it is pi plus 2 beta in crossed, not closed, it's crossed one. And in theta, in open one, it is pi minus 2 beta. So if we are able to obtain theta from this equation, substitute in the above equation T1 by T2 is equal to e raised to mu theta, we can obtain corresponding tensions. Now, maximum tension. In the given material of the belt, there will be the maximum stress for that particular material. Let that be sigma. If for the given particular material of the belt, if sigma is the maximum stress, when that is multiplied with the area of cross section of the belt. Area of cross section of the belt means the breadth of the belt into thickness of the belt. So we will get the maximum tension. So maximum tension is tension in the tight side. So T1 is equal to sigma BT. So if we know all these equations, we can solve different equations to find the power transmitted, the tension in the slack and tight sides, and also we can find this maximum stress, etc. So this is how we use the equations, and these equations can be used in belt problems. Thank you.